All right, now we're recording. Okay, we're recording. All right, so we're going to talk about the intersections of two functions and some algebra and yeah, and then I'll show you the calculator too, because honestly, the calculator is so much help with this. I mean, to not use it, it's silly. I mean, so, and I'm going to give you guys a calculator help video. I made it, like I said, I made it, and I was talking to myself. I forgot to record my screen while I'm doing it, so I'm going to redo that. But, so we're going to talk about how to do that. It says, for this first example, find the intersection. So an intersection is where the two curves cross. So you have this guy and this guy, and what she's telling you to do, that's fine. You can rewrite the quadratic in terms of y. It's helpful too for plugging it into your calculator. All right, so we're going to do the algebra first, and then we'll do the calculator. Okay. All right, so if I look at this guy solved for y. This guy, the easiest thing to do is just to move the y over. If you add y to both sides, it becomes a positive y. So this equals -1 plus y. And then if I move the -1 over, I get y equals x squared plus 2x plus 1. Okay, so everybody all right with how I solve for y? If you're going to use the calculator, you got to be able to do that. Yeah, Tucker, I'll get you. I see you there. Okay. All right. So anyway, so I solve for y. So what do I do now? They're both equal to y. The way that you find their intersection, you set them equal to each other. So what you're going to do? See, this is a quadratic with the positive leading term, so it kind of opens up, right? And this guy's a line, so there should be two places. Could be two places where it crosses. All right. So what we're going to do is combine the two equations to cancel out y. So what she's trying to tell you is, since they're both equal to y, you can replace y with x plus 7. That's what she's trying to tell you. So if I do that, I get x squared plus 2x plus 1 equals x plus 7. You see, I just set them equal to each other. Okay, now I got to solve it. Now, when you have an x squared, it's going to be some kind of quadratic. So quadratics, you always want to set them equal to 0 to solve them. Hopefully, it's going to factor. So I'm going to move the x over, minus x. And I'm going to minus 7, so I get 0. So I end up with, let me move this down a little bit. Tucker, I know you're here. All right, so it's x squared, 2x minus x is plus x minus 6. This side's going to be 0. So when you have a quadratic, you want to set equal to 0 because hopefully it's going to factor, right? That's our first choice whenever we solve these things. And it does factor. Yay. Okay, so we're going to factor it. So I need factors of -6 to add to 1. What are they? 3 and -2. So this is going to factor x plus 3, x minus 2 equals 0, right? And then so either x plus 3 equals 0 or x minus 2 equals 0. So if I move the 3 over, x is -3. If I move the 2 over, x is 2. Okay? So those would be now. Those are the x coordinates of the points of intersection. Now, when I ask you for a point, that implies that you want not just x, but y also. Okay? So you can use either equation, y equals either one of these. So where's y? Y is x plus 7. That's a nice one to use, right? So what we're going to do is come back here. So if y equals x plus 7, here we get -3 plus 7, so y is going to be 4. And so this would be the point -3, 4. And if y equals x plus 7, if x is 2, it's going to be 9. So those would be the points of intersection. I found those algebraically. Okay, I don't have to do that. I can use my graphing calculator. So I want to make sure you guys see how to use the graphing calculator. Which reminds me, I don't know why I'm off on this thing, but I always forget. There's a survey out for your instructors, so please fill that out. All right, if you love me, if you hate me, then fill it out. Okay. All right, because that does affect, I don't know, some things.
Can we fill it out for Dr. Matheson too?
I'm sorry, what?
Is there like a survey for Dr. Matheson?
I'm sure there is. That should be for all your professors.
Yeah, well, he's.
Okay. I'm not sure where it is. It's got to be somewhere up there because I got an email about it. So. All right. Are you good with that? The algebra part of it? Yes, no? Yeah. Okay. Any questions? Moving out. The graphing calculator can solve these things too. So all you're going to do with the graphing calculator is I'm going to come back to where I solved for y. So I have 2 equations. I have this one and I have that one. I'm going to plug them in the calculator and I can find the intersection points. They should be the same as what I just found. So okay. All right, so I'm going to pull my calculator up. It's here. All right, and I'm going to go in. I'm going to type into y1 and y2 the 2 expressions for y I have. Once I get the calculator up. Okay, so let me kind of clear that out. All right, so the one of them was x squared plus 2x plus 1. Type that y1. And the other one was y plus x plus 7. So I'm going to type that one in. So you got to solve for y. You're going to use the calculator. Now, all I'm going to do is graph these. They should cross in 2 points. That's what I found. So I'm just going to graph. All right, I'm going to do 6 because I'm like often spacey land. All right, so you can see that it intersects in 2 places, the red and the blue curve. Those are my points of intersection. So I'm going to go find them. So I'm going to hit second trace intersect 5. And move the cursor. I moved it up toward those. Whoops. Press enter, enter, enter. I got 2, 9. Was that one of my answers I got? Okay, so now we'll go find the other one. Second trace intersect. Move this down toward the other one. And press enter. I got -3, 4. Okay, so hopefully that's what I got with algebra. So the calculator can solve, pretty much anything you want. When they want a point of intersection, though, I want you to understand, because Thursday we talked about solving equations. That's just solving for x. When they want a point of intersection, they want x and 1. Okay. All right. Is that okay? Your calculator is actually very, very unique. Okay. In a lot of ways. All right. Let me minimize this. All right, so we're going to work through some of these the practice problems with the algebra, and then we'll verify the calculators for the practice with the calculator. So, by the way, it's number 1. There are 2 lines, and like you can do that with RRAF if you wanted to, but you tested RRAF, didn't you? In 1324. Do you do RRAF for solving systems of equations?
Yes, ma'am.
Yeah, you can do that right with lines, but we're going to do it the long, hard way. All right, so I'm going to solve for y, I guess. And I'll just solve this one. So y equals -2x minus 1. I'm going to minus 2x. That's what I did. Okay. So I solved that for y. I guess I'll solve this one for y. I really don't want to do it, but I will. All right, so I'm going to move the 5y over to the other side. So it's going to become positive 5y. You're adding 5y. Is that all right? And now we got to solve for y. So we're going to divide by 5. Divide everything by 5. Everything. Okay? So I end up with y equals x over 5 plus 17 over 5. Is that all right? Okay, so the algebraic way, now that I have to say for y, I set them equal to each other. So that means that negative 2x minus 1 equals x over 5 plus 17 over 5, right? Okay. Now, I don't like 5s on the bottom, so to get rid of that, I'm going to multiply every term by 5. Are we okay with that? That's going to throw all those fractions off because I don't like fractions. Okay. So I'm going to multiply every single term by 5. Okay. So when I do that, I'm going to get negative 10x minus 5. 5's cancel. Here I get x plus these 5's cancel, 17. All right, so now I have something that's very easy to solve. I guess I'll plus 10x on both sides. Over here, so I get negative 5 equals x and 10x is 11x plus 17. So minus 17. So that's negative 22 equals 11x. Yes, is that right? If you divide by 11, you're going to get negative 2, right? It's always a good thing when x comes out to be a nice whole number, you know, you probably get it right, right? All right. So x negative 2. They want the point, all right? So if they want the point, you have to go back and find y, all right? So just take one of your equations. I personally like this equation right here. It's a lot easier than the other one's kind of gross, right? It's got fractions. All right, so we'll deal with that one. So y equals negative 2x minus 1. X is negative 2. So I end up with 4, is that 4, right? It's 4 minus 1. I end up with 3, right? So the intersection point I'm getting for these two curves is that x was negative 2 and y was 3. So that would be my point of intersection. All right. It's on one. This is 2 lines. All right, we're going to go check it on the graphing calculator. Right? Graphing calculator can help you out with these. All right, so we're going to, in the graphing calculator, I'm going to enter both of these guys. We're going to do this one, and we're going to do this one, right? We're going to enter both of those into the calculator. 2x minus 1. Hopefully I'll get the same answer. And the other line, I forgot the equation already. X over 5 plus 17 over 5. So x over 5 plus 17 over 5. All right, I'll just figure out. And there's one point intersection. We're going to go find it. Second trace 5. And enter 3 times. And I get negative 2, 3, which is what I found using algebra, right? So I know I did it right. Okay, now on your final, it's not going to matter whether you do it algebraically or you do it on the calculator because it's multiple choice. All right. Okay, you good with that?
So whenever we're doing it algebraic or when we do it on the calculator, it's just easier. We don't have to do it algebraically, correct?
All right, Amy, you're going to need to repeat the question because your voice cut out.
So we don't need to do it algebraically, correct? That's all I'm asking. That's just an option.
Did you enter your question in chat because your voice is muted in and out? It's your internet connection.
I think she's asking if you just could do it on the calculator without the algebra.
Right. All right. Yeah. Okay. That's what she's asking. Yeah. Okay. Yeah. On the final, it's not going to matter because it's multiple choice, right? On my test, it's not going to matter because it's multiple choice, right? So using the calculator is not a problem. All right. For some of these, I actually prefer the calculator, right? So I'll do less work. All right.
So we just have to do the first step and then we can do it in the calculator?
You have to solve for y to use the calculator. Okay. You must solve for y, and then you enter y1, y2, away you go. All right. So make sure you can solve for y.
Okay.
All right, let me get this back up. All right, and like I said, with these linear things, do you remember just to kind of talk about it real quick. This is not how I'm going to do it with you guys, but this is how you did it in 1324, right? And let's start talking about it a little bit. You line these up, 5x minus 3y equals 8, and 2x minus 3y equals negative 5. Remember doing that? And you ended this matrix. And you RREF'd it to get the solutions. So that's an option. There's nothing, I mean, that's the same thing as the point of intersection, right?
So you can do it that way?
Sure.
as well?
I mean, I don't care how you can do it as long as you can solve the system of equations, right? That's what I'm trying to remind you is you have a lot of options, okay? And feel free to use whatever you are most comfortable with. All right, so we're going to solve it algebraically, and then we can do our right? So I'm going to solve the first one for y. So I'm going to move the 3y over. Well, no, it's not going to matter. I'm going to do negative 3y. I'm going to move the 5x over. Negative 5x plus 8. So when you change signs, right? Change signs for sides. All right, so divide by negative 3. And that cancels. I get y equals 5/3 x minus 8/3. If it goes plus 8 divided by negative 3, it's not going to matter. Okay, the other equation, 2x minus 3y minus 5 equals 0. I guess I'll move the 3y over. I'm going to move it over, make it positive. Divide everything by 3. All right. All right, so the algebraic way I set them equal to each other, we're going to do the algebra and then we're going to do the calculator, right? The calculator is easier, but then all right, so if I set them equal to each other, I get over here 5/3 x minus 8/3 equals 2/3 x minus 5/3. Oops, I forgot an x there. Okay. So I set them equal to each other. Now it's got 3's in the bottom, so I'm going to multiply everything by 3 and get the 3 off the bottom, right? Because I hate fractions. All right, so I'm going to take this and I'm going to multiply every single term by 3, right? And I'll cancel all the 3. So I get 5x minus 8 equals 2x minus 5. That was nice, all the fractions are gone now. Now it's easy. So if I subtract 2x, I get 3x minus 8 minus 5. I'm going to add 8. So 8 minus 5 is 3. Divide by 3. I get x equals 1. Is that okay? Now they want the points, so I got to go back and get y. Use your favorite one. I like this one. Don't know why. So if I plug in x equals 1, I get 5/3 times 1 minus 8/3. So 5/3 minus 8/3. That's going to be negative 3/3. You can plug it in a calculator if you need to, right? It's negative 1. Okay. So I get 1, negative 1. Yes, x is 1, y is negative 1. Is that right? And again, I'm going to plug this in the calculator to make sure I've done it right. Okay. Remember, RREF is still an option. It's just, you know, it's however you can solve them, right? You've got all these options available. Don't be afraid to use what you know, right? All right. We'll give them a minute, right? I'll step people in here and see what you're doing. All right. All right, so I'm gonna plug these in, all right, into my calculator. So I'm gonna prove stuff out, get clear. So the first equation was 5/3 x minus 8/3. All right, and the second equation, 2/3 x minus 5/3. You can use the fraction bar if you want. I'm just not. I'm being lazy. Good, graph it. So you can see the point of intersection there. It looks like 1, -1. We'll go find it. Second trace 5. Press enter 3 times. And there it is, 1, -1, right? Did right. Oh, she's going the calculator down here, better well, I'm sorry. I jumped the gun. All right, so same thing on the next one, solve for y, you're gonna move the 4x over, so it becomes a -4x. So this is y equals x squared minus 4x. And this one, y, I'm gonna move the 2x over, so it becomes negative. And I'm gonna move the 1 over, so it becomes negative. When you change sides, you change the sign. All right, so that wasn't too bad, right? All right, now we're going to enter in the calculator. Well, no, we're going to do the algebra. I'm sorry. I'm going to go to the calculator. All right, so the algebra tells me I'm going to set these two equal to each other. All right, so this is what I have to solve. It has an x squared. Because it has an x squared, I'm going to move everything over and set it equals 0. I'm going to plus 2x. And then plus 1. So this side's 0. This side's x squared. -4 and 2 is -2x. Okay. And can we factor that? Can we factor it? We find factors of 1 that add to -2. Yeah, -1, right? All right. So this factor is x minus 1 times x minus 1, which is really just the same factor. So the only solution to this is x minus 1 equals 0. So x would be 1. All right. Plug it into your favorite equation for y. I like the first one. So if y equals x squared minus 4x, you can plug it into either one. I get 1 squared minus 4 times 1. So I get -3. Okay, so the point of intersection is 1, -3. There's only one. Okay. Now, that might be a little bit of a surprise because it's a quadratic of a line. Sometimes there will be only one. All right, we'll see what this looks like. So we're going to graph it and see why I get one solution instead of two. So I'm going to go into my calculator. I'm going to verify that we graph both of these. And see why we're getting what we're getting. X squared minus 4x. And clear this out. And the other one was -2x minus 1. -2x minus 1. And we're going to graph. All right, so you can see that that line just kind of comes down and scrapes across the parabola, so it only touches at one point, right here, somewhere in here. So we get the second, cal, intersect, enter, enter, enter. All right, and we get 1, -3, which is what we got with algebra. Okay, so feel free to use that calculator, right? It can be from help. So, all right, more algebra. Okay, yeah, we'll just keep doing that. All right, so this one, I solved for y here, right? This one's good to go. This one, all I gotta do is move the 8x over, so it becomes a -8x. Okay, so I just move this over. So I'm gonna set them equal to each other. That means that -5x squared plus 12x plus 3 equals -8x plus 18. All right? Okay, so I'm gonna move everything over. Now, I don't like a negative leading term, so I'm gonna move everything over to the right-hand side to make the negative 5x squared a positive, just split on factor with the negative up front. So I do have some method to that. So the 5x squared, I'm gonna add 5x squared. Minus 5x squared. There we go, minus 12x. We're gonna minus 3. This side 0. I get 5x squared, negative 12 and negative 8 is negative 20. And 18 minus 3 is 15. Okay? Now, 99% of all things you're going to get are factorable, but this looks horrible the way it is right now, right? Because what's the first thing you always do when you factor? Common factor. Is there a common factor I can pull out? Yeah, we want to do that, right? Because otherwise life is hard. So I'm going to pull out 5. I'm left with x squared minus 4x plus 3. Now this is something that's a lot easier to factor, right? So I need factors of 3 that add to negative 4. What are they? Good, negative 1 and negative 3. So this is going to factor x minus 1, x minus 3. Yes? So set the factors to 0. So x minus 1 equals 0. So x is 1. Move it over, make it positive. X minus 3 equals 0. Move it over, make it positive. Okay. Oh, I want points. So I'm not done. Guess what I get to do? I have to go plug it back in, right? Okay. So I personally like this equation. It's easier to work with. So if x is 1, y equals negative 8x plus 18. So if x is 1, I get negative 8 times 1 plus 18. That's going to work out to 10. All right, so 110 would be a point. If x is 3, I get negative 8 times 3 plus 18. I'm just plugging it into here. So I get negative 24 plus 18, 6, negative 6. Okay, so the other point is 3, negative 6. Okay, and again, you can plug this into your calculator. I'm not going to do it because I've been doing that 3 times, right? Be okay, okay, we can do that. Anybody? Okay, just plug it in and find the answers.
Way quicker.
Huh?
It's a lot quicker.
It is. That's, in this particular type of problem, I would much rather use my calculator. All right. But they do want you to sit down for us. All right. So this last one, it's 2 quadratics. So you might have 2 solutions. I think you even have 4. You're not going to have 4. All right. So we're going to solve for y. This one's good to go. This one, I need to move the stuff over. So I get y equals negative x squared. The negative 6 comes over and becomes a positive 6. And the positive 8 comes over and becomes a negative. All right. I've got everything on one side. All right. So algebraically, I set them equal to each other. So I get 4x squared minus 4x minus 3 equals this guy, negative x squared plus 6x minus 8. Okay? And it really doesn't matter which side you move it over to because it's going to be positive no matter what. No, it's going to, I want to move to the left because I want to add x squared, right? So either positive 5x squared or negative. I don't like negatives. So I'm going to add x squared. I'm going to subtract 6x. And I'm going to add 8. Right? This equals 0. 4 and 1 is 5. Minus 10x. 8 minus 3 is 5. That looks almost familiar. All right, not quite. Now, what's the first thing I want to do? Factor out that 5, right? Get rid of it. If you take out a 5, right now it's so much easier to factor, right? so you factors of 1 and add to -2. And we already did this, right? Once today. Right, -1, -1. So it's 5 times x minus 1 times x minus 1. Fancy way to say that is x minus 1 squared. So set x minus 1 equals 0. So move the 1 over, you get x equals 1. All right. So we gotta find y. You can plug it in either one. I'm gonna plug it into this one. All right. So y equals 4x squared minus 4x minus 3. If x is 1, it's 4. Let's say I get 4 minus 4 minus 3, -3. Okay. So my solution is 1, -3. And again, you can verify this on a calculator. All right, calculators are your friends. You good? Any questions? All right, so she's laying out the steps for the TI-84, which we just already did, right? So if you ever wonder where they are, they're right here, right? Okay. Second trace 5. That's what you need to remember. All right, and she wants us to go back and find the intersection, which we did while we were working on this out. Okay. So she rewrote the problems we just did, and she just wanted to do them not the same. I did mine concurrently rather than in a row. Okay. All right, so function notation. I don't know why they stuck it in 10.3. This is like really 10.1, but for some reason we stuck it here. You know, like a function notation is a way of giving something a name. So like in calculus, a lot of times you're dealing with different functions. Like I might have one thing, I might have one equation that, you know, y equals 2x minus 3, and maybe another one that y equals x squared. And I want to talk about them, but I don't want to use all their names. So what we can only spell them out every time. So what I do is I might call this one f of x. And I might call this one g of x. So they're like names. This is Franklin Gertrude. All right, so when I talk about g, you know which one I'm talking about. That's why they do that. All right. The x is not multiplying. The f of x, it means f is a function of x. So that's like your y is replaced with f of x. All right. X is what they call the independent variable, and y depends on what x is. So therefore, it is f of x. All right. So that's your function notation. It has nothing to do with multiplication. It will never have anything to do with multiplication. Okay. All right. So, and function notation is actually very easy to evaluate. They're just telling you if they give you f of x, they want you to find this is read f of 4, which is basically just telling you to plug in x equals 4. Okay, that's all I got to do. So they plug in 4 for x, and they got 2 times 4 plus 5. 2 times 4 is 8. Right, plus 5 is 13. All right, so that's all you're doing. When I ask you to evaluate f of something, you just plug that something into the function. Okay. So, and now here's really how they use it. See, what they're doing is they're giving me Frank, Gertrude, and Henry. So I've got 3 functions, and so the letters tell me which function to use, right? And the numbers tell me what is for x. So f of 3 means that I'm plugging into f, and I'm letting x be 3, right? All right, so I plug in 3 here. So I get 3 squared plus 2 times 3 plus 3. And you can plug this in a calculator, you can just do it by hand. I'm just going to do it by hand today. It's 9. This is 6. And 9 plus 9 is 18. And that's all I got to do. So you see, I'm just plugging in that inside parenthesis in x. That's all you're doing. All right. I should mention this on the TIE whatever, 84. If you have the function in the calculator already, like let's say I have the f of x in there. This is the way of checking it out. Let's see, f of x is x squared plus 2x plus 3. So one thing you can't do, x squared plus 2x plus 3. There is a button. If you hit now second trace value number 1, you can enter entering x, so I wanted x to be 3. And there's the value. X is 3, y is 18. So there's a way of you to just plug values in that way. All right, so if I want f of -1 on the calculator, since I got f in there, second trace value, x is -1. There it is. All right, I'm going to get 2. I plug it in. Okay. So the calculator again can help you quite a bit. All right, so f of -1 by hand, that means that x is -1, and we're plugging it in up here. So it's -1 squared plus 2 times -1 plus 3. -1 squared is +1 minus 2 plus 3. So I'm going to get, that's going to be 4 minus 2, that's going to be 2. This is what I got on the calculator. All right. So they want me to find g of 6. That tells me that x is 6, but now I'm going to do g, so I'm talking about this function. All right, so we just do 4 times 6 minus 3. You're going to get what, 21? All right, so that's all there is to function notation. All right, it's just a way of giving a name to an equation. All right, so g of -1, that's this one. So you're plugging in, let x be -1, so x is -1. So it's 4 times -1 minus 3. So this is going to be -4 minus 3. It's going to be -7. Okay, so you see how we're just plugging in values for x here, that's all we're doing. All right, h of 2 means we're going to do this one, right? So h of x, I'm going to write it down here. It's 4x cubed. It's h of x plus 1 over x cubed. So h of 2, everywhere I see an x, I replace it with 2. So it's 4 times 2 cubed plus 1 all over 2 cubed. And I'm going to type that into my calculator. Oh, I don't have my calculator. All right, I'm going to pretend I typed it in my calculator. Oh, I can do this. I really don't need it. All right, second quit. All right, if you want to use your fraction bar, alpha F1, number B. All right, so 4 times 2 cubed. Arrow out of that, plus 1. Over 2 cubed. All right, I get 33 over 8. So what you guys got? All right. H of -2, same thing. I'm just plugging in -2. Make sure you put parentheses around it. So I'm going to plug it in here. X is -2. Plug it in. Actually, what I can do, you know how to type what you just got. So I'm going to show you a trick. I'm going to hit second entry, and that's what I just typed. Then go back and replace all those 2's with -2's, right? Well, it might be a little faster. I don't know. So all I'm going to do is go back here, and I'm going to insert negative. And on the bottom, I'm going to insert parentheses, putting parentheses around negatives and negative. And another parenthesis. 31 right. All right. Okay. So you see I'm just plugging stuff in the calculator, it's all I'm doing. Now, before I jump onto new stuff, I want to make sure, because you're going to see this in 1325, and I don't know why they didn't put it here. They can ask you a question like this. Where does g of x equal 6? Now, that is not telling you to plug in 6, right? G of x is 6. So what you're doing is g of x is 4x minus 3. what they're doing is they're giving you y, so they're telling you that that's 6. Okay. And then I can solve for x. So if I add 3 over, I get 9. Divide by 4. Right? So x would be 9. Okay, so if the number's on the outside, it's y. If the number's on the inside, it's x. Any questions? Are you good with that? With function notation? Yeah? Yeah. All right, so what we're gonna do, we're gonna go up and hit 10.3 and do stuff.
I have a question real quick. It's not about that part. It's about the other stuff that we just did.
Okay.
On, I think it was like the last problem we did, or that one and the one before it. I just did it in the calculator, and on the X, I got a different answer.
For this 5 or 4?
I think it was for that one, or no, it's the one above it.
One above it? Okay, let's make sure I did it right.
I got 1 and 10, but I could have put something in wrong, but.
Oh, 110 is one of those. See how I wrote 110 here?
Oh, okay. I was looking. Okay, I'm sorry.
Intersection points, so right, it's gonna cross twice, right?
Okay.
All right, good?
Yes.
Now. All right, so this to quadratics. All right, so we're going to talk about this stuff as rational function. All right, a rational function has the word ratio, which means it's a fraction. So we might have x's on top and now x's on the bottom. So here's the deal. Wherever the bottom equals 0, it's where you have a vertical asymptote. So when you have a rational function, there's only one exception that they don't talk about, that I'll talk about as you may. If the factor, if this thing, let's say I gave you this instead. Now I just set the bottom to 0, but you see how this factor cancels with that factor? That's not a vertical asymptote. All right. It turns out that's what we call a hole, which should be interested in 1325, but I'm just saying that's not a rational asymptote. That's not a vertical asymptote. Only the bottom. The factor has to be in the bottom. All right, so basically define vertical asymptotes. Just set the bottom to 0. So I set x plus 2 equals 0. So x equals -2. And if I set x minus 3 equals 0. X equals 3. This is the equation of the vertical asymptote. We need an equation, not a number. It's x equals, because it's a vertical line. Okay. And in calculus, you're going to talk about 13.5. You're going to talk about what happens as x gets really large. As x heads to, well, I'm just going to go over here. No, I can do it. You're going to talk about what happens as x goes to 3. What happens to y? If I go to 3 from the positive side, from above it, it's going to infinity. It's getting larger and larger and larger. If I go to 3 from the negative side, it's going smaller and smaller. It's going to negative infinity. All right. So vertical asymptote can split something like that. Okay, well, let's talk about domain. Okay, domain you're going to have to do. So the domain of it, I want you to think about where those vertical asymptotes are unallowable values of x, because it makes the bottom equal to 0, right? The bottom cannot equal 0. So my domain, I know that x can be -2 and it can be 3, right? That's what it's not allowed to be. So, but here they're going to look at in interval notation. So my suggestion to you is draw a number line. Here's -2, and here's 3. And it can't be those, so it's a little open circle. So it's everything except those numbers. So basically, I have an interval for this, I have an interval for this, and an interval for that. So 3 intervals I need for my solution. So this is negative infinity, and this is infinity. All right? So the way this first interval is from negative infinity to -2. And I use a round bracket because I'm not including -2. This is a little union in between it. The second interval is from -2 to 3. That's this piece. Round bracket because we're excluding 3. Union from 3 to infinity. Okay, so that's how you're going to have to write that domain. My suggestion is to write it out in number lines so you can see how many intervals. Each one of those lines I colored is a different interval, so I've got 3 of them. All right? Is that all right? Okay. All right. So here we go. Here's the graph of x plus 3 over x plus 2. So if you look at this, if I said x plus 2 equals 0, I get x equals -2. That would be my vertical asymptote. So here at -2, if I draw a dotted line, that's my asymptote. See, it never crosses that vertical asymptote. The graph will never cross it. It can x can't be -2. So I know my domain is x can be -2, right? It's not allowed. So how do I say that? Well, here's my number line. Let's make this -2. So it's basically everything except that, so I can do this piece and I can do this piece, right? So I'm going to have 2 intervals. My first interval is from negative infinity to -2, right? Put a union in between them, and we go from 2 to infinity. And that's its domain. Is that right? Yes, no? I really hate that I can't see your faces, so all right, nice, okay, I got 1 thumbs up, so, all right. You okay with that? You can do that. Are you already or no?
I think we're starting.
Starting?
He just posted the lecture for
Okay,
tomorrow.
okay.
Wait, would that other 2 not be? It wouldn't be negative.
Oh, yeah, it is a -2, right? Okay, don't call me, it's -2, so this should be a -2, right? Just left the -1. Okay? All right. So it's, the domain's all real numbers except for the bottom equals 0. That's always the case, right? So that's what I asked myself. I find it helpful to draw it on a number line like this so you can kind of see how many intervals you have to have. Keep it straight. All right, so plug in the numbers by hand to find function values. Why would you do that? I would use a calculator. All right, well, we'll plug them in by hand. So you guys tell me, it's -1 in the domain of that function. Can I get an answer? If I plug in -1, I get -1 minus 3 over -1 minus 1 times -1 plus 0 plus 1. Right? You see what's going to happen? What happens when you plug it in a calculator? What does it say? What does it say? Oh, but it says error. Yes, no? What does it say? Well, let's try it. Let's go to my home screen. I'm going to do all this in the whole thing. All right, so -1 minus 3. -1 minus 1. -1 plus 1. I can enter the whole thing in, that's a little long, but I could. All right, so it says what? error divided by 0. So that tells me, oh yeah, it's a vertical asymptote because it makes the bottom equal to 0, right? So we get an error. So this is nil. Okay, it's not a function, so an error. Now, an easier way to do this is to go to your table. I don't want to plug these all in my hand. So I'm going to go to my calculator. I'm going to enter that function. I'm going to go into y equals. Under y equals. All right, and I'm going to enter that. So I'm going to use my fraction bar. And I'm going to do x1 is 3. I'll need parentheses on the top. I'm going to need them on the bottom. All right, why am I doing this? It's going to save me some time. All right, just to here's the graph. A, all right. So, but what I want to do is go to the table because that gives me all the values, right? So I can see already that 0. Whoops, where's my table and my calculator go? I can plug it in my hand or just look at the table, right? When x is 0, y is 3. All right, so there's no point in me going through all that calculations. I'm not sure why I should just do that. I can just copy it from the table in my calculator. So this is 3. Is it in the domain? Sure, right, because we got a value out. Right, the value in, we get a value out, it's in the domain. Is 1 in the domain? Let's go to our calculator. See, 1 has an error. So 1 is not in the domain. That's another vertical asymptote. All right. Let's see, 2, 3, and 4. All right, let's go look in the table. So 2, 3, and 4 look good, right? You got values out. Yeah, negative 1/3, 0, 1/15. So these are all yeses. Okay. So where you see those errors are your vertical asymptotes. Good. Okay. Find the domain of the rational expression below. Set the denominator to 0. Okay, so this is the same thing. I'm not sure why she's making it. I really don't care about the numerator for the domain. I only care about the bottom, the denominator. So I'd set a squared minus 25 to 0. Okay, I need to have a factor. It's a minus 5, a plus 5. And if I set them to 0, I get 5 and negative 5. So what I do is I do this extra step. I'm going to exclude negative 5 and I'm going to exclude 5, right? So I've got 3 regions. So the first one is negative infinity to 5, negative 5. Round brackets. Union the second one's negative 5 to 5. Union third one, 5 to 3. Okay. All right, so this is going to involve some factoring. We'll check on the calculator. All right, so what do I care about with rational functions? I don't care about the top, I only care about the bottom. All right, so I'm going to set the bottom equal to 0. All right, and this is going to factor, right? So you need factors of 4 that add to negative 5. It would be what?
Negative.
A negative 4 and 1 and negative 1. Okay, so this would factor x minus 4, x minus 1. All right. So if I set them equal to 0, I get x equals 4. And move the 1 over, I get x is 1. All right. So 1 and 4 are not allowed. All right. So on my number line, here's 1, here's 4. So I'm going to have 3 intervals. All right, so the first interval is negative infinity to 1, 4. Second interval, 1 to 4, or the third interval. We're good then. All right. Yeah, it's the same thing over and over and over and over and over again. All right. All right, the bottom can be 0. Now, because these are whole numbers, let's take a look at the calculator. What you'll see is errors. You should see an error of 1 and 4 on the calculator. So when I graph this function in the calculator, let's see, x minus 3 is still the same. We can edit this. I'm just going to type in x squared minus 5x plus 4. So I can avoid the factoring here that's by looking at the calculator. All right, so if you look at the graph, you can see it's got 2 places. Go to the table. See, I have an error at 1. And if I scroll down, I have another error. So this is my root class types. All right, x equals 1, x equals 4. All right, allow. All right. Oh my gosh. All right, let's see. You want to do all of these 4, or how many of these you want me to do? You guys tell me. Can I do all of them, or 1 more, 2 more? Somebody offer an opinion. 1 more? Okay. I hear a 1, so that's where we're going. All right, so 1. All right, so let's do this one. All right, it's probably hard to back. All right, so I gotta set the bottom to 0. All right, so I need factors of -14 and add to -5. What would they be?
-7 positive.
-7 and +2, right? So this is gonna factor x minus 7 times x plus 2, right? That should equal to 0. So either x minus 7 equals 0, or x plus 2 equals 0. So if I move to 7, x is 7, and move to 2, x is -2. So that's what x cannot be, right? All right. So to get the domain, I'm going to put those numbers on a number line. -2 comes first. An open circle. 7. So I've got 3 intervals, right? All right, so first interval, -infinity to -2. Union, second interval, 2 to 7, right? Union, third interval, 7 to infinity. Okay, that's my domain. Is that right? Everybody good with this? Yeah? Any questions? All right, so basically what I want you to understand, the domain is the opposite of the vertical asymptote, all right? So the vertical asymptote is a value that's not allowed in the domain, all right? So when you have a function like this, to find the vertical asymptote, we set the bottom equal to 0. -2. You get x equals -2. That is the equation of the vertical asymptote, right? That's it. Okay? So the domain is x cannot be the vertical asymptote. So the domain is x cannot be -2. And again, we're going to write this correct as interval notation. So here's my number line. -2 is out. We have 2 intervals. We got this guy. We got this guy. So it's -infinity already up here. -infinity, and we stop at -2, jump over it, and then we do 2 infinity. Okay? So the domain is that x can't be the vertical asymptote. So it's the opposite. One's equal, one's can't. Guys, okay? Yeah. All right, so she likes her examples. All right, let's do the bottom. I am almost certain. So if I set the bottom to 0 here, all right, you're gonna have factor x squared minus 4.
Do the square root.
Square roots, right? It's called difference of squares. So this is x minus 2, x plus 2. So here I get x equals 2. Here I get x is negative 2, right? Those are my vertical asymptotes. So it's x equals 2 and x equals negative 2. Okay? My domain is the opposite, right? So for the domain, I know that x cannot be negative 2 and x can't be 2, right? Again, I'm going to put them on a number line. Some open circles. All right, negative infinity. And this interval, that interval. Right? So we have the first interval is negative infinity to negative 2. Then negative 2 to 2. I'm going to ask you a question. Then 2 to 3. So when you're working with rational functions, can any of those brackets be square on the domain? Ever? No, right? Because you're excluding numbers, right? So there's, and it's going from infinity, so it's never going to happen. You're always wrong. Oh, yeah. Okay. So let's do this one. So I set the bottom to 0. If x squared equals 0, what does x equal? 0, right? The 0 squared is 0. So x cannot, x equals 0. That's your vertical asymptote. And so the domain is x cannot be 0. We exclude 0. We got this interval and this interval. So negative infinity to 0. See how factory is coming back to Monty, right? Factory is really important. All right, so this next one here, set the bottom to 0. All right, now I have to factor. How do I factor? What do I do? Yeah, take out the x, right? That's the common factor. Take out the x, and you're left with x plus 3, right? So I get x equals 0. This guy, and then x plus 3 equals 0. And x is negative 3. So those are your vertical asymptotes. All right, so vertical asymptotes. All right, domain, do your number line. I'm leaving off negative 3 and I'm leaving off 0. Oh yeah, this interval, this interval. All right, so the first interval is negative infinity to negative 3. Union, negative 3 to 0. Union, 0 to 3. I do not care about the top when I'm finding domain. Do not care. Okay? You'll find in calculus that when the factors cancel top and bottom, it's not a vertical asymptote. Next. All right, you good? All right. Do you want me to do number 5? You guys tell me. Yes, no, no. See a lot of those. It's the same thing. All right, so all for y when given a. So this is the same thing. I don't know why we're doing more of this. F of 8, you're plugging 8 for x, right? That's what you're doing. So you do 3 times 8 plus 6 over 8 minus 2. Work the top, I get 24 plus 6. The bottom, 8 minus 2 is 6. 24 plus 6 is 30. So I get 5. And again, you can type this into a graphing calculator if you're unsure of your math. In a lot of ways, we're going to graph. Here's my graphic. Here, all right, alpha F1 and over D. 3x plus 6 over x minus 2. A lot of ways I can get this value. I can go to the table and look for f of 8. F of 8 appears to be 5, which is what I got right from the table. I can also do second, trace the value, and oops, let's say x of 8. And guess what I get? Okay, lots of ways to do it. All right. Okay, now this is different, all right? Part B is just find x if y equals 9. So we're not setting x to 9, we're setting y to 9. The y is the f of x thing, right? So this tells me that this is going into 9, okay? So 9 equals 3x plus 6 over x minus 2. Okay? And we can solve this on a graphing calculator, but I won't work 3 out with you. This is like 9 over 1, right? That's the way I do it. I cross multiply. So you multiply this equals that. That. So it's 9 times x minus 2 equals 1 times 3x plus 6. Cross multiply. All right, so I'll get 9x minus 18. Just distribute. All right, I'm going to minus 3x. I get 6x minus 18 equals 6. I'm going to add 18. 18 to 6 is 4. So 6x equals 24. Divided by 6. And x equals 4. Okay. So this tells me when y is 9 and x equals 4, there's a couple ways to deal with this. I'm going to show you on the calculator. It's different because y is not x. You don't just set top value. So one thing I can do, a couple things I can do is type it into the grapher succinctly. Yeah. And so now what we're going to do is I'm going to look at my table. Now, sometimes this works. Is there a y value of 9 somewhere? Oh, yeah. See here, y is 9 right here. So I'm going to read x is 4. So I'm just reading that right in the table. I'm going to do y now. The other thing you can do is type y equals 9. Because really what you're doing is solving, right here, you're solving this equation, right? So I can type 9 and y2, and then I have y1 and find the intersection, right? All right, so I can also do that. So let's take a look at that. All right, see there's an intersection way up top here. All right, I'm going to find it. Second trace 5. I center 3 times. Oh, there's one thing about that. The cursor has to be on the right branch of this graph. It wasn't, so give me an error. All right, second trace 5. I'm going to move the cursor so it's near to the intersection. It has to be on the other side. Here it is. I center 3 times. And y is 9, x is 4. Okay. You see all I'm doing is solving this equation here. That's really all I'm doing. I'm plugging in into the calculator. Solving this equation. Okay. All right, so find the domain. So this is the same thing we've been doing. How do you find the domain? How do you find the domain? Since I've asked this to be done 20 times now.
So if you just plugged in,
You're going to
are you
set,
talking about receipt?
set the bottom to 0, right? Because
Yeah.
that's what x can't be. So if x minus 2 equals 0, x equals 2. So I know that x can't be 2. That's the domain, right? I'm going to write it in interval notation. Here's 2. Got one interval here, one interval here, right? So It's negative infinity to u. Okay, so the domain just set the bottom to 0, and that's what x can be.
What time do we get out of this class?
4:15. I don't know how to do it. I got enough time. Okay. I think we're just about done, aren't we? Oh my gosh, she's got so many problems on it. We're about done. All right, so do I need to do 5a, find f of negative 3? What do I do with the negative 3? You guys tell me.
Plug it in.
That's x, right?
Oh.
So just plug in
Yes.
x equals negative 3 to get your answer, right? Okay, can you go through that? This is getting monotonous. All right. All right, when they give you y, it's different, right? Y is where this goes in for s, so I have to solve 5 equals x squared plus 1 over x squared minus 3x plus 2, all right? Given a choice, I would solve this on the calculator, right? Plug one side in y1, one side in y2, and find the intersection. So that's what we're going to do. All right, one side's 5, the other side's plus 1. All right, make sure I got it right, get graph. All right, you see there's 2 places where it crosses? All right, I'm gonna go find them. Second, trace 5. Enter, enter, enter. All right, so one solution, I'm solving for x. Do I care about y? No, right, only x. So x is 0.75 or 3/4. And I gotta go find the other one. So I do second, trace 5. Before you hit your enter 3 times, move the cursor so that it's over on the other side. What happened there? 5. Okay, it's there, right? It's closer to the other side now. So press enter 3 times. Negative 3 is the other solution. Okay. All right, so your calculator can be a big help, right? All right, otherwise, I'm going to do a little bit more algebra. All right, she's got some practice problems. All right, look, we're going to do one of these one, and I'm going to do this one here to start. All right, so this is how they combine it all into one thing. So we want to be able to find the domain for class and jokes, so they don't want those. Find f of 2 and find x of y equals 2. So this is kind of putting it all together. So I'm going to take the bottom and set it equals 0. And that'll factor minus 3x plus 2. All right, so you can solve that maybe x equals 3 and x equals negative 2. So that's what x cannot be, right? Right, because those are your vertical asymptotes. So here's my number line. Negative 2 and 3. All right, so we have 3 intervals. 1, 2, 3. So negative infinity, negative 2. Union, negative 2, then what? 3. Union 3 infinity. That should go away, right? So if they ask me to find f of 2, what do I do with that 2? Plug it in. I'm going to use the calculator because I'm going to use it anyways on the next one. All right, so I get x squared. I'm going to type it in. X squared plus x plus 6 over x squared minus x minus 6. All right, so there's the graph. If I want to find f of 2, I'm going to hit second trace. I guess it's the easiest way to do it, value. and x is 2, so when x is 2, y is 3, or negative 3. Okay, and find x if y equals 2. So if y equals 2, that means you're going to go over here, and I'm going to go into y2, I'm going to set y2 equal to 2. Graphic. See there's 2 intersections? I'm going to go find them. All right. So the second trace intersect. Got to get over on the right part of the curve. So one's at negative 3. We'll find the other one. Where's the calculator? There it is. What happened with my calculator? There we go. All right, we go find this guy, right? So second trace 5. Intersect. I'm going to move it over so that I'm over on the right piece. Hit the arrow key. There we go. Enter, enter, enter. And I get 6. Okay. So negative 3 is 6 here. Okay? All right? So that's the goal here. All right? So you should be able to find the domain, the vertical asymptotes. Given an x, find y. Given a y, find x. Okay? We're done. Okay. All right. So like I said, it is due Sunday. I should test review up for the second test. Next Friday is the second test. All right. Don't forget to post your discussion forum. Don't forget to take the quiz. All right. 10-2 and 10-3. Okay. So,
The other day on Zoom, what I was trying to ask is, there's the review and practice homework.
Yeah.
It's not turned on. Could you turn that on? Just for the last quiz I
if
studied.
you can't review, all right, I'll turn it on. I'll figure it out. I thought I had it still on, so it could, but is it the homework that's not turned on?
It's not on for any of them. At least I didn't see it. I can show you.
It should be by grade, or should be by review.
Miss Miller? It's Jacob. I have 2 questions actually.
Huh?
Okay, I don't understand, I understand like majority of this. There's some things I just don't necessarily understand. Is there like a way I can come in like to like have like a meeting or whatever, like, or do you do that?
What are you talking about? Would you repeat your question? Like, real good here.
Like there's like I understand like majority of this, but there's like some parts like I do not understand, and I've watched like videos over it, and I still don't necessarily like understand it. Do you like have office meetings or like or whatever?
I think he's asking about your office
Oh, I
hours.
have office hours Tuesday, Thursday from 1 to 2. That's a good time to meet with you, right? Zoom?
Can I just email you to set up an appointment?
No, I'm there every day from 1 to 2. Just
Oh,
go
okay.
to the link that's in the syllabus, and I'm there.
Yes, ma'am. And my second question is, I don't know if you forgot or it's just my grade book or something about our overall grade in your class. It's still like not there.
Yeah, I didn't see mine either.
I set this so we're building numbers. What the heck? All right, you just hold on. All right, I'm gonna. Oh, who came in late? I forgot. Let me fix that real quick. It was Tucker. All right. Let me do this. I'm sharing my screen, right? So, all right, I'm going to fix this once and for all. So grades, right? And I'm going to go to Steve's. Come on. I have it set to percentage now. I should show you the percentage.
Yeah, like we don't even get that. Like they don't give us an overall percentage. It gives us like our participation. Like it gives us the actual grade, but it doesn't give us the like grade for the class. Like it gives us the grade.
Set to release adjusted final rate. Release the final rate. Drop the rate item, which I guess was an automatic final rate adjustment. Why is it not showing you? I can tell you what it is, but I'm not sure why it's not showing it to you because I have it set to do it. I mean, it's set.
This is what it pops up like.
Final grade release.
Isn't it?
Allows you to modify or enable. Let's try this one. Let's try one thing. All right, try changing that. Does it show the grades now? You have to refresh your browser.
Yeah.
Go down the bottom. What the heck? Oh, maybe because the final exam's not on there. It's a percentage, so it can't calculate without the final. Yeah, that's why. I wonder if I could go, let me see, I'm gonna play. All right. That's why they do points. All right, let me try something. Treat, okay, so where's the schemes? We're gonna go to a point scheme and see if it'll release it. That's why they do points. Hopefully it'll be all right. Where's the point? Where do you see a point? Set up wizard, we go back. Oh, I'm doing KL anyways. Let me go to MN. I think I know what it is. I'm gonna try one thing. What are you guys? Progress. I want MN. All right, no, you're KL, aren't you?
Yes, ma'am.
Never mind. All right, let me stay here. All right, so let's try this. Progress, grades. All right, so let's try. So I've got a calculated grade. I mean, Jacob, right now, you're sitting at a 61. Did he leave? No. All right, so let's do this.
Did you say 61? Did I hear that correctly?
Yes,
Okay, thank you.
that's because that test.
It-
Okay, let's try. I'm going to try something though. While I've got you guys here, let me try going to a point scheme. Let's do the start. Okay, so let's do points. It works. All right. All right, does it release the final grade now? You might have to refresh your browser. Release it?
It doesn't look like it.
Oh, yeah, refresh it again. Oh, wait, I haven't finished this yet. No. Grade scheme, symbol points grade. All right, let's hold on. I gotta save it. I need to save it. All right, hold on. Try it now. We're gonna hit refresh. Do you have it?
You want me to look at how PS is and see how it's still? Because I know we can see.
His, yeah. Did you have how he? Let me see how he is. If he is. For some reason, it's not releasing it. I thought it was. Because I can see the grades. That's his. So what do you really want from?
It's like a different place.
Choose. This is our grade scheme. Manage grade schemes. I've got a percentage. Right, set range, set wizard. Automatically release on grade. I'm going to go back. I understand why it would release percent, but it should release this. Adjust the final grade. Let's try this one. I'm just trying everything.
It's all good. Stuff's pretty.
Draw under again. Got that. Continue to keep file rate updated. Continue. Continue. All right, finish right now. Go ahead and update. Scroll down to the bottom, make sure it's not listed on the bottom. How is it supposed to release it? I mean, this is silly, it says release it. Huh?
You look on class progress.
I mean, I have the grades and I can see it grades just fine. Sure. Let's go here, progress. Grades. Yeah, I'll take a look at it. All right, so your grade is coming out to a 94.
94.
Yeah. And let's look at it. Well, it's only one quiz, I mean, yeah,
I did it the first time on half runs, 55.
Yeah.
I studied all day.
oh, well.
I don't know if I.
Well, I curved the test, it wasn't,
No, it was on the quiz.
oh, that's
I
one,
don't know if
that's
I
one
entered it
quiz.
wrong.
Yeah. What I'm not understanding, why is this not releasing this to you guys? I mean, I can see it. Just don't get it. You figure it out. Great. That's progress. We have people on that. Oh, the grades are there on past progress. You have yours? That's right. I see it there too. I don't have a grade, I don't have a grade for you. I didn't, say, section 85, 20%.
Does it have the grade?
Because the homework grade is 100%, yeah, I'm not. What in the world? I don't know what's going on. I'm gonna have to. I'm not sure why it's not releasing the final grade. I know, I'm gonna email Carol and ask her what I need to change. Because I don't know what it is. I mean, I'll try.
And you don't have office hours on Fridays, right? I was just- Thank you. Have a good day.
I'll figure out a way. I can.